Assalamualaikum warahmatullahi wabarakatuh dan selamat pagi, good morning. Today we continue with the part chapter 5, part 1, point estimation and interval estimation. Okay, the previous chapter that we cover on prescriptive statistics. So this is to represent the summarize of the data by using graph or statistic, for example using means and standard deviation. So the next part of our syllabus is on inference statistic. Inference statistics, so how you want to make conclusion based on the data you collect. Because when you collect the data based on certain sample to represent the value of population. So in inference statistic, the two major activity of inference statistic. One is to use the sample data to estimate value of the population parameter, and second to test hypothesis or claims made about the population parameter. So how you want to represent or estimate value from the population. This is applied in your project 2. Okay, this one is project 1. This one is your project 2. Okay, and then the second, how you want to test the hypothesis or claim from the population. Because you cannot do the all data, so you need to do the sampling of data. But from the sample you collect, how you want to represent the meaning from the whole population. That's the meaning of inference statistic. Okay, what are points and interval estimation of population parameter? So the point estimations is a single value that is our best guess for the parameter. Okay. Interval estimation is the interval of a number. This means you have range of number, for example 5 to 10. Okay, within which a parameters value is believed to fall. Okay, and this one is point estimation or interval estimation. This is the mean of single value. Okay, this is the meaning of the interval value. So this means you have the range of data. A point estimation predicts a parameter by the single value. The interval estimation is interval value that are believed value for the parameters. Why a point estimation alone is not sufficient informative. So point estimation doesn't tell us how close the estimation is likely to be the parameters. Okay, interval estimation is more useful. Is incorporate the margin of the error. Okay, the margin of the error which help us to gauge the accuracy of the point estimation. So point estimation, how you do make the best guess for the population parameter by using the appropriate sample statistic. For the population mean, use the sample mean. For the population proportion, use the sample proportion. This is example lah how you want to calculate. Point estimation are the sample common from the inference report by the media. This means if you're looking for the media, for example, the number of oxidant per month, maybe they just put one number, maybe 400 per month. So mostly, okay, this means the statistic used in everyday life. Okay. Okay, they just use only one value. They not use the interval value. Okay, properties for the point estimation. There are two types of properties. One is a good estimation has a sample distribution that center at the parameter. The estimator with the properties is unbiased. The sample mean is unbiased estimator of the population means, and the sample population is unbiased estimator of the population proportion. Okay, property 2 is a good estimation has a small standard error compared to other estimator. This means it tends to fall closely than the other estimation to the parameter. Okay, this is example. Okay, the true values. So the good values, that means you have the value in the centers. Okay, but this one is show the bias because the true value is on the uh, left. Okay, bias in distribution is not center. Okay, unbiased in distribution is center at the true value. Okay, this is important for you to plot the graph. Okay, however, both of this style of graph, I think the last uh, chapter we already mentioned which one is better, which one is biggest and lowest graph, or thinner and slim graph. Okay, unbiased, but they are large standard deviation, so it's not precision. Okay, that means they have the large standard deviation. But this one, the slim and thin graph, but it has a smaller standard deviation. Okay, this is more appropriate to use. This means the data is more spread. This one, the data is not spread enough. Okay, so that's why they have the bigger standard deviation. Interval estimation, constructing a interval that consists of parameter. Okay, the inference about the parameter should provide not only a point estimation but should also indicate the likely precision. Okay, interval estimation. Okay, they to to know the estimation by using confidence interval. So confidence interval is the interval contain the most believable value for the parameter. The probability that this method produce an internal that consists the parameter we call is confidence level. There is a number of choose to be close to B1, most likely 0.9%. This is the value we call as the confidence interval. Okay, but if you looking read of the paper, I think most of the paper they already mentioned this. Okay, and the others is what the logic behind constructing confidence interval. The construct a confidence interval for the population proportion start with the sample distribution of the sample proportion. Okay, we need to have the confidence interval because we collect the data based on simple, but we want to produce from the sample what the meaning to the population. And the sample distribution of the sample proportion give the possible value that sample proportion and their probability. The estimation is normal distribution for the large sample or random sample. It has a mean equal to the population proportion and has standard deviation called a standard error. Okay. Margin of error. The margin of error measure how to accurate the point estimation is likely to be estimated in parameter. A distance of 0.19 standard error is the margin error for 95 confidence interval. Okay. So this one, we will continue with the next class, okay, to discuss how to calculate the margin of error. Okay. So today just the term. You need to understand the term and why you need to uh, why we need to represent the sample, to represent the data on the whole population, because possible for you to collect data. For example, you want to calculate the average uh, average PE from UTM student. So if you do have the raw data, you need to use the study by using the survey. But the population is high. It's possible for you to collect all students in UTM, so you might be use the case from the certain faculty. This is the idea of this chapter lah. Okay, thank